Okay, so solving quadratic equations by factoring. Look at the steps that we have here. We need to move all of our terms to one side. It doesn't matter which side, they just need to all come together on one side and set the equation equal to 0. That's very important. Then next, you're going to factor from using all the methods that we've gone over in the past couple of weeks. Next, you'll set each factor equal to 0 and solve for x, and then write your answer as a solution set. Okay, so looking at problem number 1, we have x squared plus 9x equals 0. As I look at this, I see that I already have everything on one side and it's equal to 0, so I don't have to do that part of the process. Now the next thing I want to do is I want to take this left side, x squared plus 9x, and I want to factor it. So let's go through the steps. First thing we always look for when we're factoring is to take out a GCF. Since I have x squared plus 9x, that tells me that I have a GCF here. So when I have a GCF, I'm going to divide by that GCF. Since our GCF is x, let's bring it down. X squared divided by x is x, and 9x divided by x is 9. So now I have x times x plus 9 is equal to 0. Since I've factored using a greatest common factor method, I'm now going to take each factor and set it equal to 0. So I have x, and I'm going to set that equal to 0, and I have x plus 9, which I'm going to set equal to 0. Now x equals 0 is already solved. X plus 9 equals 0. I'm going to subtract both sides by 9 and get x equals negative 9. So my solution set is x is equal to negative 9 and 0. Now looking at my next problem, I have x squared minus 4 is equal to 0. I look at these two terms and I see that there is no GCF, so I'm ready to start factoring. This is a difference of two squares. I've got minus, perfect square, and perfect square. When you factor a difference of two squares, you're going to have a binomial times a binomial. Remember, one of them has to have a minus and one of them has to have a plus. To get the terms of the binomials, I need to take the square root of each term up top. So the square root of x squared is x, the square root of 4 is 2. So my factored form is x minus 2, x plus 2. Now to solve this equation, since it's in factored form, we take each factor and set it equal to 0. Now let's add 2 to both sides to get x is equal to 2, and subtract 2 from both sides to get x is equal to negative 2. So my solution set is negative 2 and positive 2. Number 5, I'll look at my polynomial and I see that we have no GCF other than 1, so I'm ready to factor. Since this is a trinomial and we have a 1 as our leading coefficient, that tells me I can take 21 and I can list the factors. Now to multiply and get a positive 21, we have to have same signs. Since the middle number is negative, that means all of my factors should be negative. So both of these multiply to 21, and negative 3 and negative 7 add to give me negative 10. So now we're going to put x minus 3, x minus 7 in factored form. Now that I've factored it, I'll take each factor, x minus 3 and x minus 7, and set both of them equal to 0. So let's add 3 to both sides to get x equals 3. Then we'll add 7 to both sides to get x equals 7. So my solution set is x equals 3 and 7. Okay, now number 7, as I look at this one, I notice there is no GCF other than 1, so that means I'm going to factor my trinomial where a is greater than 1. So to do that, I'm going to multiply 3 times negative 30, and this is going to be my multiplication number. So now I'm going to list the factors of negative 90. So let's just list the factors of 90. 1 times 90, 2 times 45, 3 times 30. 4 is not a factor. 5 and 18, 6 and 15, 9 and 10. Now, to get a negative, we need opposite signs. Since my middle number is negative, that tells me that my biggest factor should be negative. Okay, now all of these factors will multiply and give me negative 90. I'm looking for the factors that will also add to give me negative 13. That's going to be 5 and negative 18. So let's bring down 3x squared. We're going to replace our middle term, which is negative 13x, with positive 5x and negative 18x. Those are my two factors that I just found. And then I'm going to bring down the negative or minus 30. So looking at this problem, we can now see that we have four terms. So we're going to factor by grouping. So we'll make a group 1 and a group 2. Looking at group 1, we see our GCF is x. Looking at group 2, we see our GCF is negative 6. The reason I chose negative for this second GCF is because the groups have got to match in signs. Group 1 is all positive, group 2 is all negative. So to change all negative to positive, I have to use that negative 6. Now let's divide by x. That'll give me 3x plus 5. X squared divided by x is x. X divided by x is x to the 0, which is 1. 1 times 5 is 5. Now let's divide by negative 6. Negative 18 divided by negative 6 is 3x. Negative 30 divided by negative 6 is positive 5. Now factor out the common parenthesis, and what's left for the other parenthesis is your two GCFs. Now take each factor and set it equal to 0. I'm running out of room, so I'm going to kind of come over to the side here. We've got 3x plus 5 equal to 0 and x minus 6 equal to 0. To solve, we'll subtract 5 from both sides to get 3x equals negative 5. Divide both sides by 3 to get x equals negative 5/3. Here we're going to add 6 to both sides to get x equals 6. So my solution set is x equals negative 5/3 and positive 6. At this point, you might be thinking to yourself, should I divide out negative 5/3? Well, look what happens on your calculator when you divide out negative 5/3. If you take negative 5 and divide it by 3, you get a repeating decimal. So the only thing that you would want the decimal for is to plot a point on the coordinate plane. Other than that, we want to leave it as negative 5/3 because that's a precise, exact number. It's not rounded, and so we can plug it into our equation and check it easily. So do not divide out into decimals if you can avoid it. All right, looking at number 9, I see that I don't have equals 0 like I did before. So what I need to do is I need to move all of the terms to the same side. Since 2x squared is positive, I want to keep it positive. So I'm going to move the 5x to the other side by subtracting 5x. Now I've got 2x squared minus 5x is equal to 0, which is exactly what I need in order to factor and solve for x. Looking at the problem, the first thing I look for is the greatest common factor, and I see that the greatest common factor is x. So I divide both terms by x. 2x squared divided by x is 2x. Negative 5x divided by x is negative 5. Now take each term and set it equal to 0. The first one is already solved. The second one I have to solve. Let's add 5 to both sides and divide both sides by 2. Now this would give you a terminating decimal. However, we're going to leave it in its fraction form. Number 11, I have 2x squared on the left and x squared on the right. So I need to move everything to the same side, so one side will equal 0. So I have to figure out which one I want to move. If you have squares on both sides, always move the smallest square to the largest square. That'll keep your squares positive. So to move a square, I'm going to subtract it from both sides. Now I'm also going to have to move that 1. So since it's a -1, I'm going to add 1 to both sides. So when you're adding and subtracting variables, just add and subtract the coefficients in front. 2 minus 1 is 1. So that'll give me 1x squared. -50 plus 1 is -49. Now over here, these are opposites canceling out and giving us 0. This is a difference of 2 squares, and since it is a difference of 2 squares, we'll take the square root of each one to get x minus 7, x plus 7. Now take both of these and set them equal to 0 and solve your equations. Add 7 to both sides to get 7. Subtract 7 from both sides to get -7. So x is equal to -7 and +7. On number 13, we have our square on the left and it's positive, so it needs to stay on the left. So that means we're going to take 80 and we're going to move it to the other side. So we'll have x squared plus 2x minus 80 equals 0. This is regular trinomial factoring, so let's take -80 and list the factors. 1 times 80, 2 times 40, 4 times 20, 5 times 16, 8 times 10. Now to multiply and get a negative, we need opposite signs. The biggest one needs to be positive. So we're going to make all of our little factors negative. So all of these will multiply and give me -80. We're looking for the one that will add to give me +2, which will be -8 and +10. So my factored form is x minus 8, x plus 10 equals 0. Now take each one and set it equal to 0. And subtract 10. And so my solution set is -10 and +8. Now on number 15, we've got 2x squared and x squared. We want to move the smaller x squared to the larger x squared to keep it positive. So we'll subtract x squared from both sides. We also have to move the minus x, so we'll add x to both sides. When you add and subtract variables, add and subtract their coefficients. 2 minus 1 is 1x squared. -9 plus 1 is -8x. Minus 65 equals 0. Now let's find the factors of -65. Okay, now we need opposite signs, biggest one negative. Now both of these sets of factors will multiply to give me -65, but only 5 and -13 will add to give me -8. So that'll give me x plus 5, x minus 13. Take each x and set it equal to 0. Subtract 5 to get x equals -5. Add 13 to get x equals 13. So my solution set is -5 and +13. All right, so number 17, we're going 2x squared is positive, so we're going to leave that there. So we'll subtract x and we'll subtract 21 from both sides. That'll give me 2x squared minus x minus 21 is equal to 0. Since there's no GCF, we're going to multiply. 2 times -21 is a -42. So let's list the factors of 42. 1 times 42, 2 times 21, 3 times 14, and 6 times 7. Now we need opposite signs, biggest one negative. So let's make all of our big factors negative. Now, all of these multiply to give me -42, but only 6 and -7 will add to give me -1. So let's bring down 2x squared. Let's replace -x with +6x and -7x. And then let's bring down -21. Let's make group 1 and group 2. 2x squared plus 6x has a GCF of 2x. Negative 7x minus 21 has a GCF of negative 7. Because group 1 is positive and group 2 is negative, we need to take that second group and make it negative so that both groups will have the same signs. So putting our 2x in the front, 2 divided by 2 is 1, x squared divided by x is x, 6 divided by 2 is 3, and then the x's cancel out. 7 over 7 is 1, that'll give me 1x. Negative 21 divided by negative 7 is positive 3. Factor out that matching parenthesis and put your other parenthesis as your two GCFs. Okay, now let's take